installing Soothsayer 1.11 onto Windows using Podman. First of all, we're going to go ahead and create a machine. We need a virtual machine. So Podman machine init Soothsayer. This uses the Windows Subsystem for Linux to create a Fedora image in this case, and then it copies in some drivers so we can exploit our hardware, such as the GPU. We need to use the GPU. So this makes our virtual machine. You can see the virtual machine from the settings here. If you go down to Podman settings, keep an eye on there. Soothsayer has appeared and it's off. Okay, and it's got access to all the resources on the host, so it's very capable. So Podman machine start Soothsayer. This starts up the virtual machine, and you can verify that from here again. So we're now green and we've started. So that's just a VM. We haven't installed any Docker containers yet. What I now want to do is copy in some software. So let's copy in some software. So Podman machine, and then we're going to CP the software that we've downloaded onto the machine that we've created, and we're going to put it into temp because we're a user and everybody can put stuff into temp. We're going to have to move that once we get on the machine because temp gets reset after a reboot. It's 1.7 gigabytes now. It's much smaller, so it doesn't take as long to copy stuff in. And if you want to access the machine, there's two ways to do it. You could either do Podman machine and then SSH Soothsayer, or if you've only got one machine, if you run the Windows Subsystem for Linux command, you'll see we've only got one. You can just do WSL. It's much quicker, and then that gets you into the machine. So we're a user here, and if we go into /cd temp, you can see the software that we copied into our machine. We need to move that out of here. Put it in opt is a safe place to put that. So if we want to put that in opt, we're going to need to use sudo. And now it will persist a reboot. And it's a fairly neutral place to put software. If we want to unpack that software now, we're going to need to use sudo because of the folder that we're in here. Sudo tar-xf to unpack the containers. So 1.7 gigabytes, pre-built images in here, and it makes it much quicker to install, as you'll see in a minute. Before we can begin to install the containers using the container install script, we need to just check the environment is good and it has a GPU. So the command to test for the GPU is NVIDIA SMI, and if it says command not found, don't worry. It's a bad path on Windows Subsystem for Linux. It's a known issue with copying in the drivers. The solution is to put in a link. So you put in a symlink, and this link will link the driver that's on your VM to somewhere that's in your path, so that now if I run that command again, different result this time. We have a 4070 GPU with a CUDA driver. That's exactly what we need. We're happy. We have a driver and GPU pass-through, which is perfect. So the next step is to install the container toolkit. Just because you've got the driver going doesn't mean that it can be used. So if you go into scripts, NVIDIA, and then follow that with Podman, this should install the container toolkit. I may need to put sudo in the front of that because we're about to do some stuff. Okay, so this script was about to run, but it complained about Podman Compose being missing. So we need to go and install Podman Compose. The package manager for Fedora is DNF, and if I do install Podman Compose, so that goes and fetches Podman Compose. If you're offline, you'll need to go and get those packages and sideload them. Same with the NVIDIA Container Toolkit. So the NVIDIA Container Toolkit script will go online, and so you'll need to go and get those packages as well. Just to be clear, that's the Linux packages because we are now operating in a sort of fairly native Linux environment. Now let's try that script again. Okay, progress. So it's fetched the GPU key for the NVIDIA GitHub, and we're going to install all sorts of stuff. This is the container toolkit that lets containers use a GPU. It said it already existed, configuration not added. Okay, well, fingers crossed, this will be okay. So we think we've got the GPU prepared and it's good to go. Let's go and give it a whirl. We don't need to put sudo in front of here because we're just installing containers. And Podman has been detected, GPU has been tested, and now we're copying in images. So if we go and open up Podman desktop and click on our images and keep watching that, we expect shortly to see images populating here. This release has had a refactor. We've taken 7 images down to 4. It makes it smaller, it makes it quicker, makes it easier to maintain. All the engine images have now gone into one big image called core, which is the API in the engines. The 2 web server images have now gone into a single web server with a single configuration, so you can replace your SSL certificates and it's easier to manage. The database is a standard Postgres database, and now we have success. GPU is found and verified. Would you like to enable phase tracing? So we warn people about this if you're going to put it onto a battery-powered computer like a Jetson. So it's a choice. So I'm okay with that. And the host name, you can set your IP that you're going to access SOOTHSAYER on. That's the Podman IP in this instance. The port numbers are high because it's Podman, so we're not privileged. And the password is random. You can change that later. Can we access the internet? Yes, we can. Do we want to proceed? Yes, we can. If you can't access the internet, that's fine. It just means that it won't try and fetch resources that are online. You'll have to sideload things. Right, do we want to proceed? That's the point of no return. So this is the fun bit. You get to watch the images just pop up in Podman desktop. And we're waiting for 4 images. So Postgres just popped up. Web server has popped up. The core was already there. That's the 3 gig one at the top. Okay, and map proxy is optional. It's a tile server. So now we've got images, we're expecting containers. So containers have appeared very quickly, and there's 4 containers that belong to this this compose configuration at the top here. And the containers have been brought up for the installation because it's got to populate the database. That's what's happening in the background. Lots of SQL statements are being run to populate the tables with lots of metadata about terrain, land cover, trees, buildings. That doesn't contain the actual data, it just describes the data so that when you click into a town somewhere, it knows to go and fetch all the layers from either the disk or the API, depending on if you're offline or online. Once tiles are pulled down from an upstream server, they're local, so it won't try to fetch them again, it will just use them off the disk. And for offline customers, you can go and get a data pack for your area, for your region, and just drop it all into your folder structure. The data is then all local, you don't need to be going online. This release also includes offline 3D terrain, so it generates the 3D terrain from the DEM data that's actually on the disk instead of fetching it from a third-party provider. The last one is trees. This is big. We've put millions of tree tiles into this release, so this one will take a few seconds. Okay, database is populated, password's been shown to us, and the containers have been switched off. So let's go and copy that password. You can change this later, and let's start up the containers. Now, I've got a choice at this point. I could run the start script, or I could go and click play up here. For the first time you do it, run the start script because it's going to set up permissions, and it will check permissions on various folders, data folders. You could click play here, but you'd risk the permissions not being correct. The second time or more you run it, then you can go ahead and click play. It runs NVIDIA SMI just to show you that the GPU is good, and then we're spinning up the containers, and there they are, they're all running. Okay, so Soothsayer started, and it's offered us URLs for the login. So I'm going to control and click this one here. So this is the user interface, and straight away Chrome opens this up and throws a security warning. It says your connection is not private. Soothsayer uses a self-signed certificate. So what we need to do is review this and import this certificate. So we're going to proceed, and it says it's unsafe, and in the top left it says it's not secure because it's a self-signed certificate. So what we need to do before we go and log in is we need to go and actually sort this out by downloading the certificate authority. So ca.crt is the certificate. There you go, you can see how many times I've made this video. So ca.cert is here, so I'm going to go and install that into Chrome. So if I go to Chrome security settings, and this will need to be done for each client, and open up security and manage certificates. Installed by you, I'm just going to delete that previous one and import the new certificate that I just downloaded, which is here. Okay, that certificate is now installed. It doesn't take effect immediately, so you have to restart Chrome and control click to follow that link. And now we're trusted. So the alert has gone, the connection is secure, but it was secure before, it just wasn't trusted. But more importantly, caching is now enabled in Chrome. Chrome will not enable caching for self-signed certs, and so now we're going to see a huge performance boost in the user interface because caching has been activated by using that certificate. So that was a new one on us that we learnt about during some recent testing. So just copy pasted that password again to get into the back end, and here I am. I can see the back end of Soothsayer, I can see my component version numbers. The system's not licensed, so I can't begin to provision users, but upload your license file here, and then you can go and provision a user account and start using Soothsayer.